Hey everyone, welcome back. In this video, I'm going to walk you through the Descope Backend SDK and show you how to use it to add authentication to your server-side application. This video is a companion to the Client SDK video. The Client SDK handles the front-end auth experience, the sign-in forms, session storage in the browser, and so on. The Backend SDK is what lives on your server. Its primary job is to validate the tokens that come in from the client and make sure they're legitimate before you serve any protected data. It also handles management operations server-side. By the end of this video, you'll know how to initialize the Backend SDK, validate sessions, check roles and permissions, and I'll also cover Outbound App token fetching and fine-grained authorization, since both are now part of the SDK surface. Let's get into it. So just to set the context clearly, before we write any code, the Backend SDK covers two main things. The first is session validation. When a user signs in via your client app, Descope issues a session token and a refresh token. But click into the session management docs. Those tokens then travel with every subsequent request the user makes to your backend. Your backend needs to verify that those tokens are real, unexpired, and issued for the right user. That's the most common thing you'll use your Backend SDK for. Now back to this page. The second is management. The SDK gives you server-side methods for managing users, tenants, roles, permissions, and access keys. All the admin-level operations you'd run from your backend rather than exposing to the client. Things like creating or deleting users, assigning roles, managing tenant membership, and so on. The SDK is available in Node.js, Python, Go, Java, Ruby, PHP, and .NET. The concepts are identical across all of them, so everything I show in Node.js applies regardless of your stack. Now onto the installation. It's pretty straightforward. For Node.js, you have to run this command in your terminal, and then you initialize the client with your project ID. You can find that in the Descope console under Project Settings, and what I did was in my IDE, I created an env file to store this project ID. That is the basic level setup. If you want to use management functions, things like creating users, managing tenants, or running user searches, you can initialize a separate client instance with a management key, in addition to the project ID. To initialize a management key, you can go into your Descope console, click into Company, Management Keys, and create a new one. One newer option that's worth knowing about is Auth Management Key. This is separate from the regular management key. The idea is that you may want to keep authentication-related management operations and general management operations in separate client instances for cleaner separation. You can't use both keys on the same client instance. You pick one based on what the client needs to do. You can create an auth management key in the Descope console the same way you create a regular management key. Now back in the IDE, I created an index.js file. Here's where I have most of the session validation middleware. This is the most common thing you'll use the Backend SDK for. On every request that hits a protected route, you pull the session token out of the authorization header, which you can see here, and then you validate it. If the session token is expired, but you have a refresh token, you can either refresh it separately or use the combined call that validates and refreshes all in one go. This combined call is the one most apps end up using in their middleware because it handles both cases automatically. Now, one thing that's been added is optional audience claim enforcement and validate session. If we scroll down, we can see a little code snippet with auth info with audience. This lets you verify that the token was actually issued for your specific application and not just any Descope project. It's important in backend-only flows where you're issuing tokens for specific services and don't want tokens reused across different parts of your system. You can use JOT templates in the Descope console to customize the odd claim if you need to set it to something other than your project ID. Once the session is validated, the auth info object returned contains the user's roles and permissions from the JOT claims. You use the SDK helper functions to check those rather than parsing the JOT yourself. For multi-tenant apps, you scope the check to a specific tenant, but this example is just a simplified version. And also, if you want to get back which roles or permissions actually matched rather than just a Boolean, there are matching functions for that too. Those look something like this. It is also worth clarifying how JOT validation actually works under the hood, because this comes up a lot. JOT validation with the Backend SDK is treated as offline by default. The SDK caches the JWKs. the JSON web keys used to verify token signatures locally. So when a token comes in, validation happens against the cached keys without making a network call to Descope servers. If that validation fails, the SDK will attempt to fetch a fresh set of keys from Descope's well-known endpoint and retry. But under normal operation, validation is fast and local. This means that even if your backend has limited outbound internet access, JOT validation will still work as long as the keys have been cached at least once. The full offline validation docs are at docs.descope.com under Session Validation if you need to configure this more explicitly. There are two logout functions to know about. Logout is the most commonly triggered on the front end, but it can also be triggered server-side from the backend, for example, as part of an admin action or a security event. Logout ends the current session for a user by invalidating their refresh token for that specific reason. Logout all indicates all refresh tokens for a user across every device they're signed in on, useful for security events like a detected breach, a password change, or suspicious login. After calling either of these, make sure you also clear any session cookies your app has set. So this is one of the bigger additions to the backend SDK. If you're using Outbound Apps, which let your application connect users to external services like Gmail, Slack, Salesforce, GitHub, etc., the backend SDK now has methods to fetch those third-party tokens on behalf of a user. Let's look at this GitHub template. The idea is that a user grants consent to connect their external account during authentication or through a dedicated flow. Descope stores that OAuth token securely. Then when your backend needs to act on behalf of that user against the external service, you call the SDK to retrieve the token. That looks a little something like this. The SDK handles token refresh automatically, so you don't have to worry about whether the stored token is still valid. This is especially relevant for AI agent use cases, where your backend or agent needs to call external APIs on behalf of users without storing those credentials yourself. Now, if we go into authorization and click on the FGA tab, for apps that need more granular access control than roles and permissions alone, Descope has fine-grained authorization. FGA supports relationship-based access control and attribute-based access control, letting you model things like user X can edit document Y because they're a member of Team Z that owns the document. The backend SDK exposes FGA checks through Auth-Z service. You can check who can access a resource, what resources a user can access, and more. That looks a little something like this. For high-volume applications where you're making a lot of FGA checks, there's also an FGA cache option. You can run a Descope-provided cache proxy inside your own backend cluster and point the SDK at it via FGA cache URL. Repeated authorization checks then drop to sub-millisecond latency. Let me show you how all of this is working. First, here's a public route. No token needed. Anyone can hit this and get a response back. And now here's a protected route with no token attached. You can see it returns a 401 straight away. No token, no access. Now I'm signed in on the front end via the client SDK of my React app. When I click Call Protected API, the React app grabs the session token and attaches it to the request header automatically. And there we go, we have a valid session, and you can see the actual user ID and email being returned from the token validation on the server. That's the backend SDK doing its job. It received the token, validated it against our Descope project, and returned the user data from the claims. And that's the full picture. The client issues the token, the backend validates it, and your protected data only flows when the token is legitimate. To recap, the SDK has two main jobs: session validation, where you pull the token off the incoming request, validate it, and check whatever roles or permissions you need before serving data, and management, where you handle users, tenants, roles, permissions, and access keys server-side. On top of that, you've got outbound app token fetching and FGA for more advanced access control scenarios. The full reference is at docs.descope.com. Feel free to also watch our linked video on the client SDK for more details on the front end. Thank you for watching.